Okay, so here's an idea that I have. I know that a good portion of my audience, right? Um, I realize that the ones who tend to be, I would say, the ones who lean towards the preparation for PEP, most of that audience would be on my Facebook page, whereas my audience on YouTube would lean a little bit more towards the CSEC, right? The CXC and that sort of thing. So I figured I might as well, just seeing that I saw this picture here, and I did, well, I believe I did the due diligence of having a lot of these questions zoomed in, so that's a lot easier to see. Now, there's a little secret to these. Now, all of these are quadratic expressions, right? Not necessarily equations because it's not equal to zero, right? So that there's that. Now, if we had one of these being equal to zero, then there are more steps that you'd have to do from that point, right? Now, knowing about your factors is very important for this type of question. And then also about your prime numbers, because when you look at this, the only factors of 3 are going to be 3 and 1, all right? Now, this is a composite number, so this will have, quite a number of factors over here. But for 3, it's just 3 and 1, right? And of course, the first and the third term are always they're the building blocks of everything that is a quadratic expression or equation, right? So 20 is more composite, right? 40 is also composite, right? So you'll know, all right. Now, while 21 itself is composite, it would consist of prime factors, right? So, for instance, you will have 21 and 1. You will have 3 and 7. Now, the 3 and the 7 are the prime factors of 21, right? So, it's important that we know, the possibilities of the factors that we can get, right? And then prime factorization helps too, right? Because let's say, for example, a number like, let's go to 70. This one right here. Now, if we do the prime factorization for 70, we will have 7 times 10. So what you'll have is 2 times 5 times 7. Right? All of the numbers that you see there are prime numbers, right? So let me just, right? So everything you're seeing right there, right? These are the prime factors of, let me try and get this properly, hold on. Okay, wait, oh, that was weird. Yes, sorry about that. So this right here represents the prime factors of 70, right? So obviously you'd have 1 and 70, right? 10 and 7, 35 and 2, 14 and 5, right? So those are your possible combinations. So you have 1 times 70. You will have 2 times 7, which is 14, 14 times 5, right? So you'll have 14 times 5. You'll also have 10 times 7, right? And you will have 2 times 35. So the beauty of having knowledge of the prime factors, or not, well, yes, I want to say the prime factors. When you have knowledge of the prime factors, it's a lot easier for you to come up with the possibilities of the combinations that you can get, right? So you have 14 and 5, 1 and 70, 10 and 7, 2 and 35. And all of that comes from, you know, playing around with 7 times 5, giving it a 35, right? Or 2 times 5, giving it a 10 times 7. Or 7 times 2, right? Giving it a 14 times the 5, right? So having an awareness of that would be very helpful when you're dealing with factorization, right? Now, take a number like, say, 49, for instance. 49 is a square, that's 1. So, you know, you have 1 times 49. And then you have 7 times 7. And that's it. That is the list of possibilities for 49, right? So there is no further exploration needed, right? So this is all you can get from 49, right? So it's important that we are able to find quite easily the factors of both our A and our C in the quadratic expressions, because what we're going to be using is something that's called, give me 1 second so I can type it. Let's see if I can type it here. We're going to be using something called the, right? So we're going to be using something called the AC method, which the reason why it's referred to that, or rather referred to as the AC method, is because just as how you would have y is equal to mx plus c, or well, plus b, depending on where you're learning mathematics culturally, for the quadratic expression, we have the following. We have ax squared, we have bx, and we have c, right? So we have ax squared, we have bx, and c. So the a in this situation would be 36 here. The c in this situation would be, well, plus or minus 15, depending on the sign that's in front of the number. And then, of course, the b would be 47 right here. So it's always the coefficients that represent the a, the b. And of course, the number for the third term would be exactly what c would be. Now, in a situation like say, let's say we're pointing over here. A would point to positive 6. B would be negative 5. And C would be negative 4, right? So it's very important that we recognize the sign that is in front of each of the variables, right? Or not just the variables, but each member of the expression, right? So okay, just so that it makes sense, right? Contextually, right? Let's try and rewrite 6x squared, right? Minus 5x and a minus 4, right? So yeah, minus 4 here, minus 5 there. Now, just so that we see how it makes sense. If you look on it like this, now it makes a lot more sense. Because it's almost as if you're making a summation of a positive 6x squared, a negative 5x, and a negative 4. No, the plus sign just shows that you are adding this to a negative value here and a negative value here. So all you'd have to do now is just point C to this, point B to this, and point A to this. So just like that, it's a lot easier for you to identify the A, the B, and the C of any of the, wait, give me a second. Right. So just by rewriting it, it makes a lot more sense to us then. Because by doing it like this, we don't make any mistake about how to correctly identify the B's and the C's. Because typically, the B's and C's tend to be difficult to identify if there's a negative sign, right? The A's, most of the time, you don't get a negative A. It does happen, right? Because you do have quadratic expressions that have what you call a maximum value instead of a minimum value, right? So as a result, you will have negative A's in front of the x squared, right? So that is a possibility. It's just that in this situation, all of them are positive if you notice. Positive 14, positive 20, positive 2, positive 35, positive 32, positive 3, 3, 32, etc., right? So this is just how we identify our A, our B, and our C. Now, for the AC method, all we really need, honestly speaking, is the A and the C. So really, actually, we don't even need the sign itself, right? We just need the 6 and the 4, right? That is really all we need. So there's something that is done under normal circumstances, right? Normally, you would have the 6 multiplied by the 4 since AC is the same as A multiplied by C. So if you are trying to write AC, what you really mean is you're multiplying A by C. So typically you would have 6 multiplied by 4, giving you 24, and you would find the factors of the 24 to see what combination of those factors would result in giving you B, right? So B is highly dependent on the factors of A and C, right? That's really what it boils down to, right? Now, let's write the prime factors of 24. I think it's a bit longer than 2, 5, and 7. I think in this case, we're going to have, all right, 8 is made of 3 2's. So we're going to have 3 2's, and we're going to have a 3, right? So that means, let's get rid of a few of these over here. All right. So typically we have 1 times 24. We'll also have 2 times 12. All right, we'll have that. We'll also have 4 times 6. We'll also have that. We will also have 8 times 3. Right? So those are the possibilities of combinations that we have. Right? Now we have to use a combination of the two that would result in minus 5x. Right? Some combination of these two should give us minus 5x. Now, let me explain what I mean by that. You need to either have a, let's see now, a plus 2 and a minus 12, right? Yes, if we were to, well, no, we don't want to multiply them at all, actually. We just want to find out what happens when we have plus 2 and minus 12, or positive 12 and minus 2, right? Now, oftentimes when you have two negatives in this way, typically the larger number of the two is the negative one, right? That's usually how it goes. So let's actually move this for a second. I want to just take a look at it, right? Yeah, I accidentally removed that. Let me put it back. This was minus 4 right here. Okay, so what if this was positive, right? If this was positive, it's indicating to you that of the two numbers, right, the larger of the two numbers is positive. So for example, if you had, let's say, 9 and 4, you would have a positive 9 and a negative 4, resulting in this positive 5, right? Just by example, right? So just so that you understand what would happen here. So this would be a positive 9x and a negative 4x, resulting in the positive 5x, right? So that's what would happen in the event that this sign here, if this sign here is positive, this is what would happen. Out of 9 and 4, 9 must be positive, 4 must be negative in order for the result to be positive. The larger number of the two has to be positive for the result to be positive. Now, let's do the flip side of that. Now we're back to it being negative. In that case, out of your 9 and your 4, 9 this time must be negative, and your 4 must be positive, right? So in this case, a negative 9 and a positive 4 would result in -5 right there, right? So that's really what we're doing. We're trying to find the sum of the factors of A and C. Now, if the numbers get particularly large, you try your best not necessarily to do the multiplication, right? Because there are instances where that gets really tricky to find a solution for that. And we'll see examples of that a little later on, right? We'll see examples of that. But let's use something that I think is actually going to work. Let's use this right here. Let's use the 8 and the 3, right? I think the 8 and the 3 are perfect. So let's see what happens when we use the 8 and 3. We have 8 and we have 3. Now, we can't use 2 pluses and we can't use 2 minuses. You'll either get a positive or a -11, right? So that's definitely not what we want, right? So as mentioned before, your larger number must be negative, your smaller number must be positive, and as a result of that, if we were to put x's side them, then if you add -8x to +3x, you end up with a -5x. Now, the reason why we'll be doing this is because we're going to be pulling off somewhat of a substitution. So we would be replacing -5x with -8x and +3x, right? That is what we'll be doing. So let's see what happens when we actually do that. So we'll have an 8x there, a 3x here, and of course, let's just do everything as it should be. So your 8x is going to be a negative sign. Your 3x is going to be a positive sign, and you'll have your -4. So this -5x is being replaced by -8x plus 3x, right? So I'm taking as much time as I can to just have a look at that so that we understand what's happening. And then the beauty about this is that, you know, from here on, we find our HCF, which is a lot easier to find than the LCM, right? It's a lot easier to find. Just so much easier. I mean, if you look at the coefficients of this x squared here and the 8, the x right here, then if you're finding the HCF of 6 and 8, you pretty much know what that is already, right? There's not even much of a need for an investigation, right? So let's just drop a bracket here and a bracket here. Let's drop a bracket here and a bracket here, right? So the LCM of 6 and 8 is 2, but is that the only thing we can use? Well, naturally, you have x times x, and you also have x. So, oh, that's not what, well, that's as straight a line as I could get for that accident that I just did, right? Okay, so imagine finding the HCF of these two, right? there's only one thing that you see both times. One X here and one X here, right? It is the only thing that's common to both of them, right? Now, if it was X to the 2 and X to the 3, then the answer would be X to the 2, right? So it would have to be what exists in both of the lines, right? So therefore, the HCF of X squared and X is always going to be X, right? Well, let me write the example of the X to the 3 and X to the 2 so that we have some, a bit of context here. So if we had X to the 3, right, and we had X times X, then of course, the HCF would be different. The HCF in this situation would be X to the 2, right? So it is always going to be the number of factors that exist in both of the expressions, right? So if I were to remove this here and this here, then we go back to it being just X, right? That is what would happen. Okay. All right, so yeah, I tend to overemphasize some of the simpler things, but just to be sure that everybody's understanding. So the HCF of 6x squared and 8x is going to be 2x, right? Now, what is actually happening here is there are two terms for the HCF. You have the HCF, which is one way of calling it. But you also have something that will throw people off. It is called the GCD, which means greatest common divisor. So in other words, what we are actually telling you is that 6x squared minus 8x will be divided by the 2x, right? So let me just get rid of what's over here, right? Because having an understanding of this part would be actually helpful. So let's look at 6x squared, and we're going to put that over 2x. So there you go. Now 2 times 3 over 2, the 2's will be canceled, leaving you with 3 upstairs, right? So we get rid of one x, we get rid of another x, right? 6 divided by 2 is 3x. So what we will put here is going to be 3x, right? So let's work on putting that right here. So we'll have 3x right there. All right, what about minus 8x? And the minus part is important, actually. So let's say you have minus 8x, and you place that over 2x. What would this be? Well, your x's would cancel. And notice any cancellation that takes place is actually the HCF of the two terms, right? So that's another important thing. And of course, if you have 3 2's over 1 2, 3 minus 1 leaves you with 2 of them, and 2 to the 2 is 4. So minus 8 divided by 2, you're going to have a minus 4, right? So we will just have the minus sign here, and that's going to be minus 4, right? Now, typically, once we're factorizing this type of quadratic expression, whatever you get in the left bracket will be exactly the same as what you get in the right. So the left bracket and the right bracket will be identical. As long as you can break the b into the sum of the two factors of AC. So if the sum of the factors of AC can be broken down, then this bracket on the left will be exactly the same as on the right. So we're also going to write 3x and a minus 4 here, right? Now, why would that be important? Because what you can do is you can divide this term by this one, or this term by this one. So you can divide minus 4 by minus 4. That will give us a plus 1. Or you can divide 3x by 3x, giving you the same plus 1, right? Now that we have this, we have what we need in order to correctly factorize our expression here. So let's just, so what I typically do when I'm doing this kind of question is I will point the 2x here, and I will point the plus 1 here. Now, the reason why I would do that is because when we are about to write our final answer, seeing that 3x minus 4 appears twice, we'll only write it once over here, right? So we will just write our 3x minus 4 over here. Right? Our 2x will come here, our plus 1 will come here. And so this will be our solution here. So we have a 2x here, our plus 1 here. And I believe that solves our problem, right? Now, the beauty about doing these questions is that if you are particularly good at using binomial expansion or the distributive property, then you know that if you multiply 2x plus 1 by 3x minus 4, it will result in your 6x squared minus 5x minus 4, right? So factorizing, if we're going to simplify it, it's the division to the multiplication that is the binomial expansion or the distributive property. The distributive property is the multiplication of it. The factorization is us reversing the process. And so that is technically a division, which is what we just did. Because we divided 6x squared by 2x. We divided minus 8x by 2x. We were using what is called the greatest common divisor. So what we've been doing the entire time, we've been dividing, right? We have been dividing. So again, we just have to be very, what's the word, crafty about how we find our ax squared, well, our a and our c, right? So fine, let's do another one, even though this is going to be a little bit easier to do. And I'm going to tell you why I think it's easy, right? Say, for instance, we're going to move on and we're going to do this question here, right? Whenever you see, and I want us to remember this, there are certain outcomes that are inevitable. Once you see a minus in the middle and a plus at the end, it means that regardless of the terms that you have in the bracket, right, that the two signs that are being used will be a negative sign and another negative sign. That's an inevitability. So anytime we take a look at an expression that has a x squared minus a x plus some number, if as long as it is minus then plus, then the signs that are being used are two minus signs. Now, naturally, if it is just a plus sign and a plus sign, it is two plus signs, right? So that's fairly obvious, right? But the opposite of this, right, is to have a minus then a plus, which results from having one minus sign and another minus sign, right? So that is something that it's an inevitability, right? And then of course, there's the other possibility. If you have two minus signs, then the larger number is negative, right? Well, let me just, yes, actually, yes, that's actually correct. No, again, let me explain why that is, right? A positive times a negative will always be negative. So the third term will always be negative, right? Just like what we had here, yeah? We have two negatives, so therefore the larger number 8 is larger than 3, therefore it had to be negative, right? The same is going to be true for the minus 13 and the minus 10 here, right? Now, if it were, again, if it were something like that, then of course the larger number would be positive, right? So just a few of the things that we need to look out for when we're dealing with factorizing, all right? So let's see if we can use this trick to our advantage. Let's see if we can use the AC method again. Why not? And again, we're going to be looking at, well, whoops, I just got rid of that. Let me try and use my rectangle again. There we go, all right? So we're going to be working with 35x squared minus 53x plus 20. Now, wow, okay. So this, again, notice the numbers are large, right? The numbers are pretty large. A is going to be 35 and C is going to be 20. Now, in this situation, I would not multiply 35 by 20 because that's going to be what? 35 times 10 times 2, which is 70 times 10, which is 700, right? But you know what? That's not too bad, actually. Let me show you a beauty about the number 100, right? Now, 700 is the same as 7 times 100, right? But I'm not sure if I did this on YouTube before. Maybe I have, maybe I haven't. I think I have, right? Because if you notice something about your powers of 10, right? The number of zeros tell you the number of 2s and 5s that exist in the number. Yeah, let me apologize for my biological glitching. So you have 1, 2, and 1, 5 because there is 1, 0. If you have 2 zeros, you will have 2 2s and 2 5s, right? And then, of course, 3 zeros mean you have 3 2s and 3 5s. Now, forgive me for the laziness. I really should have the multiplication sign so that we're aware of what is happening. So 2 times 5 will give you the 10. 2 times 2 times 5 times 5 will give you 100. And of course, 2 times 2 times 2 times 5 times 5 times 5 will give you 1,000, which is why 125 over 1,000 results in 1 over 8. Now, if we were to look at this in terms of the prime factors, then it would be easy to see, right? Now let's look at that and see how that would work. This right here is 125. We're going down in powers of 5. 5 to the 1, 5 to the 2, 5 to the 3. So 5, 25, 125. So we will have 3 5s up here, right? And then below, we will have 3 2s. And again, we have another 3 5s. Now, what is our HCF? Our HCF is going to be the 3 5s, right? So we can actually see that. So anything divided by itself is going to be 1, and that would result in 1 over 2 times 2 times 2. So therefore, 125 over 1,000 is always going to be 1 over, is always going to be 1 over 8, right? So it's pretty useful to remember this over here, and this over here, right? So with that in mind, we're going to focus a little bit on the 100, right? Nah, I don't like how that look. So let's do something a little more. Yeah. So we're going to use this right here. We're going to use this information right here, right? So we're going to use the 100, which consists of 2 times 2 times 5 times 5. So let us do that, right? So again, knowledge of your prime factors makes it easy to reduce your fractions and so on. And for us to deal with even this situation up here. So fine. In conclusion, our list of prime factors will be 2 by 2 by 5 by 5 by 7. All right. Now we have to figure out what combination of these would result in us getting 53, right? So that's really what we're looking for. We're looking for what can give us 53, and both numbers need to be negative because, of course, if you have a minus 40, oops, sorry, I did not remember I was using that. So let's say you have your minus 40 and your minus 13. Now, I remind my students, whenever they see the signs, once the signs are the same, you are going to perform an addition between the two numbers, right? If both numbers are positive, you add the numbers. If both numbers are negative, you add the numbers, right? Because you're not multiplying, right? Since you're not multiplying, you're going to be adding the numbers. So that's a reminder I always give to my students, but sometimes they constantly get mixed up between the addition of negative numbers and the multiplication of negative numbers. So a lot of times when they see two negatives, they think, oh, two numbers that are negative will give you a positive. But of course, that only happens when you're multiplying. But, you know, it takes a lot of practice to remember not to make that mistake. So, you know, I don't hold it against a lot of my students, right? So, how would we get that minus 53? How would we get that? So what we'd have to do, we'd have to use just a multitude of the combinations here, right? We'd have to do that. No. So here's all right. So here's the problem. The 35 and the 20 clearly don't work, right? This is our 20 right here, right? And this is our 35 right here. There's no combination of 35 and 20 that will ever give us 53. Because 35 plus 20 is what? That's 55. So that is not an option for us. It's not an option. So we have to find some other combination that will work. Something else will have to be done, right? So what could that possibly be? What could it be? What could it be? All right, so I am thinking, let's try 2 by 2 by 7. That will give us 28. Now, what do we have left? We have what? 5 by 5, which is 25. This looks absolutely perfect. That's it. Now, here's why it couldn't be two positives. This term here is negative, so both of these terms here will have to be 28x and 25x in order for us to get a 53x. But in order for us to have it correct, we need a negative 28x and a negative 25x, right? So let's summarize what I'm really trying to say. Now, where do I put all of that information? Where am I going to put it? Where am I going to put this? All right, so let's do this. Let's do this. We're going to have 35. We're going to have 28. We're going to have 25. And we're going to have 20. No, this 35 will be 35x squared. This will be 28x. This will be 25x. And of course, let's take a look at our signs. A minus 28x, a minus 25x, and a plus 20. So let me write something else so that we have a little bit of context here. So it means that our 35, our 53, and our 20. So You have minus. And you have your plus. So what we are seeing, let me use a different color. We are seeing that our minus 53x has been replaced with minus 28x minus 25x. So let's just take a little look at that so that we are comfortable with what just happened, right? Now, again, there are times when I just focus on finding the factors of 35 and 20 separately and then making the combination of the numbers here. But if you have the prime factors, you can easily find everything you need, right? Because we realized that the 35 and the 20 just wasn't going to work out, right? 7 times 5 or 7 times 5, it's still 35 either way. Now, if you add 5 times 5, 25 times 7, that number would be too large. So there's no way, there's no way we could combine 5 by 5 by 7. That number would be just too much, right? It would be a lot. So maybe we had to go and combine 2 by 2, but that would be too small. So we'd have to multiply 4 by 7. And then that gave us something a little bit more reasonable. So 4 by 7 gave us that 28 over here. And the 5 by 5 gave us this 25 over here. So now for the fun part, right? We're going to write down our brackets and see what we come up with. We're going to deal with the GCD or the HCF, right? Now, I'm pretty sure we know what it is for 35 and 28. They're multiples of 7. So naturally, you're looking at 7 as a part of your HCF, right? So you're definitely going to have that. So why not just drop the 7 out here? And of course, the HCF of x and x squared is always x. So we're going to drop that beside it. Yeah? Now, what if you weren't comfortable with that? What if you wanted proof? Well, you have your 35 here. You have your 28 here. Again, this is only if you want the proof. All right, so there we go. All right, so this will be our 5 times 7. And this will be 2 by 2 by 7. Now, now it's obvious what the HCF is. Only 7 exists in both of the lines. So it justifies having the 7 out here. Yeah? And of course, the HCF of 25 and 20, we pretty much know what that's going to be. These are multiples of 5, so it's going to be 5. Right? You're going to have 5 times 5 and 2 times 2 times 5. So what they have in common is 5. Right? So we don't even have to do that, really. Really and truly, we really don't. But we already know it just by looking at these two. Sometimes it's not particularly easy to get these numbers, seeing that it depends on the numbers that you get here. Because sometimes the numbers are very large and you don't particularly know what would be divisible into both of them just by looking. But This is a lot easier to do, seeing that you can see the separation between the 20 and the 25. The difference is 5, so it must be related to 5, right? So 35, and of course the x squared over x is always x. So if we divide this by this, naturally we'll have 5. So why not put the 5x here? Now, if you're not sure that you did this right, multiply 7x by the 5x. If you do not get 35x squared, then there's something we did wrong, right? So let's say, for example, we wrote down 5 by itself. If we multiply 7x by 5, we'd get 35x and not 35x squared. So then once we do that, we go, oh, I think I left something out. So then you know we'll write your x here. No, x times x is x squared, 7 times 5 is 35. So everything is all right. Then, of course, 28 over 7, that's 4. The x is canceled. That's going to leave you with 4. And, of course, minus 28 over 7. Well, we know what that is. All right? And naturally, we're going to put this same 5x minus 4 over here. Right? We are going to do that. 5x minus 4 and 5x minus 4. We can divide minus 25x by 5x, or plus 20 divided by minus 4. That's going to leave you with a minus 5. Right? So that is very important, because without doing this, we have no idea what sign is going to be in front of the 5, right? If you add minus 25x over 5x, the x is canceled. Minus 25 over 5 is still going to be minus 5, right? And of course, we carry out our same duty here. This appears twice, right? Our 5x minus 4 appears twice. So we write it down just once. Then, of course, we will have our 7x here, our minus 5 here. And just like that, we have factorized. Let me see if I can write this a little more user-friendly. There we go. So that's it. All right, 7x times minus 4 is minus 28x. Minus 5 times 5x is going to be minus 25x. Minus 5 times minus 4 is going to be plus 20. 7x times 5x is going to be positive 35x squared. So we have successfully found our pairs of factors that result in 35x squared minus 53x plus 20, right? And again, a lot of times students might get mixed up in terms of seeing the minus, then the plus sign, or the plus, then the minus, or the minus, then the minus, right? But as long as we remember the relationships and what causes these arrangements, then we will know that both numbers need to be negative if it's going to be a minus than a plus. Both numbers need to be positive if everything is positive. So those two parts are a lot easier to do. But when you see two minus signs, you have to remember the larger number will be negative. When you see a plus, then a minus, the larger number must be positive. So as long as we remember that combination, it should be easy for us to do. So give me a second to stop sharing, and let's see if I can let's see if I can find another set that's a little bit more difficult than this. But you know what? Let me just stop here and just say thanks for watching, and I'll see you around. And of course, I'm going to continue doing this, but when I do it, we're going to try to do some of the more complicated ones, the ones that are not so easy to find out what the factors are. So let's just have a look at that next time around. So again, thanks for watching, and I'll see you around.